Hello, Subhan. Okay, we are live right now, and just fix a few things, and then I can think we can begin. Okay. Uh, okay. So today's class is about solving all permutations and combinations questions that we can. I will be starting from the November 24 series and going backwards and seeing wherever we have to check answers, we'll check answers. Okay, let's just pick out the permutations and combinations questions and do those. Okay, that's the first question. It says find the number of different arrangements of the 9 letters of the word happiness. So happiness. Okay. So 9 factorial divided by 2 factorial into 2 factorial. Nine zero seven two zero. Find the number of different arrangements of the 9 letters of the word happiness. In which the first and last letters are not the same as each other. Okay. So I will have to come up with cases for this. What cases can I come up with? In fact, what I can do is I can just subtract the cases where I have them together, not together, the same as each other. There can only be 2 cases where they are the same as each other. That's P and P, and that's S and S. I have the total number of arrangements there. So if you have P and P at the end, this is going to become 9 factorial, and 2s will be identical, not 9 factorial, sorry, 7 factorial, and then divided by 2 factorial. It's 2520, and then 7 factorial divided by 2 factorial, that's 252. Okay, so 90720 minus 2 times 2520. 85680. Okay, I will have to check all of these answers. So I'm going to go to my marking schemes. 85680. Yeah, that's the correct answer. Find the number of different arrangements of the 9 letters of the word happiness in which the 2 P's are together and there are exactly 2 letters between the 2S. Okay, so the 2 P's are together and there are exactly 2 letters between the 2S. First, let's make those conditions. 2, 3, 4. S could be here and here. S could be here and here. Could be here and here. Could be here and here. And S could be here and here. Okay. So when you are solving this question, I want to keep the 2 P's together. So what I'm going to do is I'm going to manually count where the P's could appear. Okay, so 1, 2, 3, 4, 5. Okay, there are 5 places where the P's could appear. How many other letters do I have? I have 5 other letters, so that's going to be 5 factorial. Okay, then for Let's count where the p's could appear. The p's cannot appear at the start. So 1, 2, 3, 4. So that's 4 into 5 factorial. Okay. So the p's could appear here. 1, 2, 3, 4. 4 into 5 factorial. So 1, 2, 3, 4. One, 2, 3, 4, 5. I think I've placed an extra dash somewhere. Wait. 1, 2, 3, 4, 5, 6, 7, 8, 9. An extra one. Yeah. Just need to be careful about this. 4, 5, 6, 7, 8, 9. So 1, 2, 3, 4. Yeah, 4. So 1, 2, 3, 4, and 5. That's 5 into 5 factorial. Okay, let's see if I messed up the dashes also. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 7. Okay, so that's fine. Let's calculate all of these. 5 factorial is 120. 120 into 5 is 600. So that's 600. Okay. 4 into 120 is 480. 480, 480, 480, and 600. Getting 3120. That is the correct answer. Okay. The 9 letters of the word happiness are divided into at random into a group of 5 and a group of 4. Find the probability that both P's are in one group and both S's are in the other group. Okay. So group of 5, group of 4. Okay. If the P's are here, then the S's are here. If the S's are here, then the P's are here. Those are the two cases. If the P's are here, I have 3 more spaces in this group. I have a total of um, 9 people, 9 letters, but P's and S's are sorted out into the group um, directly. So I'm left with 5 other letters. Okay, so that's going to be 5C3 and 2C2 and again 5C3 into 2C2. 10, 10 as well. 20. Okay, yeah. 20 is the count. I want to find the probability. Okay, so probability will be 20 over 9C5 into 4C4. 20 divided by 126 gives me 10 over 63. Okay, that's the correct way of doing it. It's November 2453, I think. Next, I have May, June 2451. They're not in an order. I think I missed something. Okay, the 8 digits are arranged in a line. How many different digits arrangements are there of the 8 digits? Okay, so 1, 2, 2, 3, 4, 4, 4, and 5. 8 factorial divided by 2 factorial and 3 factorial. 3360. Okay, that's June 2451. June 2451. Okay, find the number of different arrangements of the 8 digits in which there is a 2 at the beginning, a 2 at the end, and the 3 fours are not all together. Okay, not all together simply means that not all three are together, but two could be together. Okay, so what you will have to do is no restrictions minus fours together. Okay, so in this case, the no restrictions would need to have the other restriction at least. The two at the beginning and the two at the end. So this case would be a two at the beginning and two at the end. The other numbers are 6 factorial divided by 4 factorial. So that's the no restrictions case. And then if you keep the fours together, there's going to be a two at the start, two at the end. The fours are in a box, and there are three others outside. So that's going to be 4 factorial into 3 factorial divided by 3 factorial. Okay, sorry, this is 3 factorial, not 4 factorial because the three fours. 120 minus 96. I hope that's the correct answer. Yes, that is the correct answer. 3 digits are selected at random from the 8 digits. Find the probability that the 3 digits are all different. Okay, so the choices that I have are now I want to calculate the probability. So the first thing I go on and do is calculate the denominator. Okay, so for the denominator, I have 8C3. For the numerator, I'm going to have to make cases. So the first case is going to be 1, 2, and 3 are selected. There are no choices for 1, but there are. That's 1C1 into 2C1 into 1C1 again. Okay, because there are two 2's available. Then you could have 1, 2, and 4, 1, 2, and 5. You could have 1, 3, and 4, 1, 3, and let's yeah, 1, 3, and 4, and 1, 3, and 5. And then 1, 4, and 5. And you could have 2, 3, and 4, 2, 3, and 5, and 2, 4, and 5. And then you could have 3, 4, and 5. These are all the cases that are there. I will have to add up all of these cases. So 1C1, how many fours are there? There are 3 fours. Okay. So whenever you're selecting fours, you have to be careful. That's 1C1, 2C1, 1C1, 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 3C1. 2C1, 1C1, and 3C1. 2C1, 1C1, and 2C1, 3C1. Six, two, six. Okay, what's 2 plus 6 plus 2 plus 3 plus 1 plus 3 plus 6 plus 2? That gives me 34, and the denominator is 8C3, 56. Yep, that is the correct answer. I think I did something on the marking scheme while I was solving this yesterday, so those are marks from the marking scheme. Okay. On to the next question now. The next paper is November 2451. Okay. In the back. Okay, that's the next word in which the two T's are together. I think that's simple. 1, 2, 3, 4, 5, 6, 7. So then 7 factorial, sorry, 8 factorial going into the box as 2 factorial, then divide by all the identical ones. 10080. Okay, November 2451. Let's check our answers. Okay, that's correct. How many different arrangements are there of the 9 letters in the word intellect in which there is a T at each end and the two E's are not next to each other? So T at each end, then there are 7, supposed to be 7 in the middle, but I also want to leave out the E's, so there are 5 in the middle then. Okay, so that could be 5 factorial. Okay, so the E's are out. There are 2 L's that are repeated, and so this would be divided by 2 factorial. Then for the E's, I'm going to make arrows and say that the E's could appear anywhere here, and that would be 6 places, so 6C2. I would arrange them, but they are identical, so they also need to be divided. बिल्कुल यही कर रहा हूँ मैं. 900. Okay. Then 4 letters of the word, 9 letters in the four of the 4 letters are selected at random from the 9 letters in the word intellect. Find the percentage of possible selections which contain at least one E and exactly one L, exactly one T. बेटा P1 के बाद बिल्कुल ऐसा ही हो रहा है, but you will have to still study. Okay, so I am selecting 4 letters, at least one A and exactly one T. So एक T आ गया, एक E आ गया, एक T आ गया, दो E आ गए. I am calculating the percentage of the probability, which means that I will also have to double count. Denominator भी मुझे एक चाहिए होगा. The denominator should be 9C4. For the numerator, what I'm going to do is I am going to select other letters. So T's are gone, E's are gone. Okay, one thing that's missing is that the L's could be there. L कितने आने हैं वो नहीं लिखा हुआ. But since I am already double counting, what I will do is I will count them in the rest of the group and make my choices. So out of two E's मैं एक E select कर रहा हूँ. So 2C1 out of two T's I'm selecting one T, and out of two E's I'm again selecting one E, and 1 2 3 4 5, so 5C2. So 2C1, 2C2, and 5C1. Okay. $40, and then 4 into 5, 70. Okay. Not multiply 60 divided by 9 C 4, 10/21. No, I think I've missed something here. T 2C1, 2C. Okay, this is 10, not. Yes, it is. That's 25/63. You convert that to a percentage, you get 25/63 multiplied by 100. So you get 39.7%. Okay. Okay, on to the next paper then. This is February, March 24, 5/2. Okay, ये combinations का सवाल है. A new village social club has 10 members, of whom 6 are men and 4 are women. The club committee will consist of 5 members. In how many ways can the committee of 5 members be chosen if it must include at least 2 men and at least 1 woman? Uh, at least 2 men. So 2 and 3, 3 and 2, and 4 and 1. So 6C2 into 4C3, 6C3 into 4C2, 6C4 into 4C1. That's 60, 120, okay. Okay, that's going to be 240. Let's check if that is correct. February, March 24 and 52. Okay. The 10 members of the club stand in a line for a photograph. How many different arrangements are there of the 10 members if all the members stand together and all the women stand together? So men 1, 2, 3, 4, 5, and 6, and then women. पहले तो बॉक्सेस आपस में शफल कर सकते हैं देन 6 फैक्टोरियल आई पुट इन 1 डैश लेस मैंने एक डैश कम लगाया है यहाँ पे और फिर 4 फैक्टोरियल 34560 okay. Okay, then for a second photograph, the members stand in two rows with 6 on the back row and 4 on the front row. Ollie and his sister Petra are 2 of the members of the club. How many different arrangements are there of the 10 members in which Ollie and Petra stand next to each other in the front row? Okay, so what is going to happen in the first row is कि कोई दो लोगों ने आके जो है वो यहाँ पे खड़े रहना होगा. So the first choice that I'm going to make is 8C2. Okay. And then with the boxes, it's going to be 3 factorial. Then inside the box, it's going to be 2 factorial. That's for the front row. How many people remain? There are 6 people remaining. So I'm going to say that 6C6 at the back into 6 factorial. Okay. 8 into 7 divided by 2 to 6 into 2 into 241920. Okay. Then on to the next question. I think इस पेपर में एक और होगा. Okay. This one in a restaurant. This is November 2351. Okay. In a restaurant, the tables are rectangular. Each table seats four people, two along each side of the longer sides of the table. 8 friends have booked two tables, X and Y. Okay, in a restaurant, the tables are rectangular. Each table seats four people, two along each of the longer sides of the table. 8 friends have booked two tables, X and Y. Rajas, Sue, and Tan are three of the sides of these friends. The 8 friends will be divided into two groups of four. One group for table X and one group for table Y. Find the number of ways in which this can be done if Rajas and Sue must sit at the same table as each other, and Tan must sit at the other table. Okay, so there could be two cases that Rajat and Sue are sitting on this table and then Tan is sitting on the other one, and then Tan is sitting here and Rajat and Sue are sitting here. Okay, how do we handle that? हमारे पास लोग और कितने हैं? 8 फ्रेंड्स हैं. सही है, तो 8 में से 3 चले गए. कितने लोग बचे? 5 लोग बचे. तो इसमें दो और की जगह है, और वो जो है वो अपने आप को राजद और सू के साथ अरेंज कर सकते हैं. ओके, यहाँ के लिए 3 लोग बचे और वो टैन के साथ अपने आप को अरेंज कर सकते हैं. फिर इसी तरह यहाँ पे 5C3 आ गए, एंड वो लोग आपस में अपने आप को अरेंज कर सकते हैं. और ये लोग आ गए, वो अपने आप को आपस में अरेंज कर सकते हैं. आई थिंक ये आपस में ये दोनों केसेस आपस में मल्टीप्लाई होके फिर ऐड हो जाएगा. 5C2 होता है 10 10 इंटू 24 240 5760 प्लस. आई थिंक ये भी 5760 ही आएगा. 11520. What year is this? November 2351 a.m. I am doing question number 6. November 2351. 20? Okay, this is just about dividing into groups, I think. I didn't read the question. Will be divided into two groups. Okay. I am not supposed to make them sit. I'm just supposed to divide them into two groups. So R and S and tan and R and S. Okay, I did some overthinking there. So I got 5C2 into 3C3 and 5C3 into 2C2. Okay, so 5C3 is 10. This is also 10. So that gives me a total of 20. Okay, moving on. When the friends arrive at the restaurant, Raju and Sue now decide to sit at the table X on the same side as each other. Okay, so they are sitting either here or here, and I guess it's again two cases. Tan decides that he does not mind at which table he sits. Find the number of different seating arrangements for the 8 friends. Okay, so if they're sitting at table X, there are already two possible sides that they could sit on. Okay, wherever they are sitting, they could shuffle between themselves. So that's 2 factorial. Okay, who else is sitting with them? We don't know. So we can say that out of the 6 friends, 2 other people will want to sit with them. And those two people can also arrange themselves. All the other people will be on the other table and they will certainly arrange themselves. So that's 2880. Okay, that's correct. As they leave the restaurant, the 8 friends stand in a line for a photograph. Find the number of different arrangements if Rajat and Sue stand next to each other, but neither is at the end of the line. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. So what I can simply do is I can imagine a box that's going to go around Rajat and Sue can be here. 2, 3, 4, 5. There are 5 positions where Rajat and Sue could be there. So 5 factorial, they could switch between themselves. So 2 factorial. How many other people are there? There are 6 other people. So that could be 6 factorial. Okay, let me check if that is the correct way of thinking about this. Hmm. I think, okay, sorry. This has to be 5, not 5 factorial. Yep, that is the right way of thinking about this, not 5 factorial. This is just 5 different positions, so 5. Okay, 7200. Moving on, this is May, June 24, 5-3. Let's see what we've got here. Okay. So this is June 24, 5-3. So recorders. So 9 factorial divided by 3 factorial and 2 factorial. 30240. How many different arrangements are there of the 9 letters in the word recorders in which there is an E at the beginning, an E at the end, and the 3 R's are not all together? So I'm just first going to find all of this without keeping them together, just unrestricted combinations. unrestricted arrangements. There have to be 7 in the middle. So 7 factorial. How many r's am I dealing with? I'm dealing with 3 r's. So 7 factorial divided by 3 factorial. There's no restrictions. If I don't want not all together, so what I have to do is I have to make a box. Keep them together first. 1, 2, 3, 4, 5. That's 5 factorial going inside the box. 3 factorial dividing by the identical. Okay. So I have 7 factorial minus 120. Giving me 720. Okay, what year is this? June 2453. Let's open that up. Yep, 720. The 9 letters of the word recorders are divided into random groups, a group of 5 letters and a group of 4 letters. Find the probability that the 3 are in the same group. So पहले denominator decide कर लेते हैं. Denominator is 9C4 into 9C5 into 4C4. Okay, with unrestricted access. This is getting uploaded. Group of 5, group of 4. Okay, so the R's could either be here or the R's could either be here. In case the R's are here, then 3 R's are gone and I have 6 other letters. So 6C1. I don't have 6C2, sorry, 6C2 and then 4C4. And then I have 6C1 and 5C5. That's 15. That's 6. That's a total of 21. And 21 out of what? 9. 5. 126. 1/6. That is the correct answer. March 2352. Okay, this is February, March 2352. And find the number of different arrangements of the 9 letters in the word delivered in which the 3 E's are together and the 2 D's are not next to each other. Five, 6. Okay. If I don't want the D's to be next to each other, so I should skip 2 of the dashes first. So that's 5 factorial divided by 3 factorial. Now the D's could appear 1, 2, 3, 4, 5, 6. 6C2 into 2 factorial divided by 2 factorial. 300. February, March 2352. The correct answer. The correct answer is 1800. Have I missed something? Oh, I didn't do the box. Oh, wait, I've done something else. Okay, I've missed out on the fact that the e's are in the box, so that's 3 factorial, so that should be divided. Okay, let's do this again. 120 into 50. Yeah, that is what my answer was missing. Because I have to arrange the box so that I can divide it by the identicals. In this 5 factorial, the e's did not get arranged. That is what I missed when I was calculating. Okay, find the probability that a randomly chosen arrangement of the 9 letters in the word delivered has exactly 4 letters between the two D's. 2, 3, 4. 4 letters between the two D's. So that's 4 into 6. That's 3 more. The D's could be here and here, and here and here, and here and here. Okay, the 3 E's are there, so the identicals get arranged. That's 7 factorial divided by 3 factorial. All of these are 7 factorial divided by 3 factorial. Okay, so 4 into 7 factorial divided by 6. That's 3360 for the numerator. I want to find the probability. So I will have to calculate the denominator as well. So that's 9 factorial, 3 factorial, and 2 factorial. Gives me 1 over 9. Okay, that's the correct answer. 5 letters from the 9 letters in the word delivered. Find the number of different selections of the 5 letters. Include at least one D and at least one E. Hello, Ibad. Okay, at least one D and at least one E. So I could have two D's and one E. And I could have, let's just do cases for one D and two E and then three E. How did it go? Leak तो नहीं हुआ? Okay, so the D's and E's are gone. So I have 4C3, 4C2, 4C1, 4C2, 4C1 and 4C0. 4, 6. चलो शुक्र बच गए. 4 and 1. So 10, 20, and 25. I don't know if that's correct. Yes, that is correct. अभी देखते हैं वैमन का क्या होता है. Let's wait. Okay. फिर आ गए हम मई जून 23 5 2 है ये. And we have question number 6. In a group of 25 people, there are 6 swimmers. हाँ वो एक डिजिटल कॉपी घूम रही थी. मैंने पहले कहा था कि डिजिटल लीक नहीं हो सकता. अगर फोटोज पेपर की ली हुई होती, फिजिकल पेपर की, फिर पॉसिबिलिटी होती है. आई डोंट नो व्हाट हैपेंड फॉर CS though. In a group of 25 people, there are 6 swimmers, 8 cyclists, and 11 runners. Each person competes in only one of these sports. A team of 7 people is selected from 25 people to take part in a competition. Find the number of different ways in which the 7 can be selected. If it consists of exactly one swimmer, at least 4 cyclists, and at most 2 runners. Swimmers, cyclists, runners. चलो that's good. बस मैथ पे ही मसला है लोगों का. Exactly one swimmer, at least 4 cyclists, and at most 2 runners. ये तो एक केस हो गया. तो ये at least cyclist हैं तो ये कम हो सकता है. Okay, so 6C1, 8C4, 11C2. 6C1, 8C5, 11C1. 6C1, 8C6, and 11C6. पिछले साल से बेटा मसले ही चल रहे हैं, खत्म ही नहीं हो रहे. So 26964 आ रहा है मेरे पास टोटल. Calculator wouldn't help you in calculating the distribution of the probabilities. अभी मैंने लास्ट रिव्यू क्लास की थी, उसमें मैंने कैलकुलेटर वाला पोर्शन बता दिया था। नॉर्मल डिस्ट्रीब्यूशन में हेल्प करेगा, बायनोमियल में हेल्प करेगा, मीन मीडियन मोड निकालने में हेल्प करेगा, नॉट अपार्ट फ्रॉम दैट। कौन सा पेपर है? मई जून 2352। Yep, that is the correct answer. I don't know that mode honestly. अभी S1 recap and review वाली वीडियो है बेटा। For another competition, a team of 9 people consists of 2 swimmers, 3 cyclists, and 4 runners. Team members stand in a line for a photograph. It's from last Tuesday. In a line for photograph, how many different arrangements are there if the 9 people of the swimmers stand together? The cyclists stand together and the runners stand together. सबके अपने अपने बॉक्सेस आ जाएंगे। बॉक्सेस के नीचे डैशेस आ गए, सो दैट्स 3 फैक्टोरियल। हर बॉक्स के अंदर जाएंगे 2 फैक्टोरियल, 3 फैक्टोरियल एंड 4 फैक्टोरियल। देयर नो आइडेंटिकल things as such when you are arranging people. So I get 1728. Okay, that's the correct answer. How many different arrangements of the none of the cyclists stand next to each other? The cyclists को मसला है, बाकी किसी को मसला नहीं है। साइकिलिस्ट 3 हैं, बाकी 6 लोग हैं, तो आप 6 को पहले अरेंज कर देंगे, 1 2 3 4 5 6। ओके, तो 6 फैक्टोरियल, 3 4 5 6 7, the 7 places where the cyclists could appear and they would arrange themselves. 120, 25200. I've missed something. I've done an incorrect calculation. कैलकुलेटर पे गलत टाइम किया था मैंने। Save the rest of the things correct. Yeah. Okay, I think we'll stop here for today. And if you need help with more questions, you can certainly ask, and I will be willing to solve them for you. For tomorrow's class, what I'm going to do is I am going to solve February March 25 paper. Are you giving P3? मैं P1 कैंसिल हुआ था। ओके, P1 कब कैंसिल हुआ था? P1 कैंसिल हुआ था, एंड इफ यू गिविंग एन S1 एग्जाम तो S1 की बेसिस पे होगा पॉसिबली, बट रिगार्डिंग मैथ इट्स अ लिटिल अप इन द एयर बिकॉज P1 का लीक वाला इशू था। तो देखते हैं क्या डिसाइड होता है। ओके।